All right, so we're continuing our discussion about functions, and now we're going to get a special type of function known as a piecewise function. All right, so consider the scenario in this department store, and there's a sign that says if you spend under $100, everyone's going to get 10% off. If you spend $100 to $500, you're going to get 20% off. And finally, if you spend $500, you get 20% off. There's a lot of times, especially like coupons you get at stores at the mall, where depending on how much you pay, depends on what percentage you get off. But how would you expect this as a function based on how much you spend? Because if I plug in, say, 90, I'm going to get 10% off, so I'm going to pay for 90% of that $90, 10% off. But if I plug in, say, 150, well, if I plug in 150, I get 20% off, so I'm only going to pay for 80% of that 150. All right, so depending on what number I plug in, I have a different number here that I'm multiplying by. And this isn't the way our functions have worked so far. The way our functions have worked so far is that if I plug in something, I follow the same rule every single time. If I plug in 2, I multiply it by 3. If I plug in -1, I also multiply it by 3, that type of thing. All right, so now we need a new type of function that can do different things depending on different inputs. And these are going to be called piecewise functions. All right, so you can think about they're broken down into separate pieces, all right, for depending on what input you're plugging in. All right, and the main thing we're going to focus in this video is evaluating a piecewise function. All right, how do I plug in values into my piecewise function? First, I did to figure out which rule I'm actually using. All right, so this might be confusing for now, so let's look at an example. All right, so this is what a piecewise function is going to look like. It's still called f of x. It's still called the function f, but it's broken up into different pieces. So I have the kind of top half and the bottom half of this piecewise. And it can be more than 2 parts. We'll see an example that's more than 2 parts in a second. But this one's broken up to 2 parts. So it gives you the rule on the left-hand side and then the input values on the right-hand side. And you'll see piecewise written a lot of different ways. So I write them with the for. Some people will just put a comma. Some people won't put anything. It'll just say 2x plus 1, x less than -1. All right. So you'll see it piecewise a bunch of different ways. But generally, they'll always have these big curly brackets to tell you that all of these pieces are being a part of this one function f. So if I want to evaluate f of -2, remember this is what that means. I want my x value to be -2. I just need to figure out the correct rule to use. So I need to figure out which category on the right-hand side this fits into. Is -2 less than -1, or is -2 bigger than or equal to -1? So I just need to figure out which one of those is true, and then that's the rule I'm going to use for -2. And of course, -2 is less than -1. So I'm going to use the top rule, which says I use 2x plus 1, but again, I'm replacing the x with -2 plus 1. So it's just like I'm plugging into a normal function, but I have to do that one extra step first to make sure I'm using the correct rule. And I get -3. And so f of 2 is -3. All right, what about f of 3? Well, again, I have to look at my input first. Is 3 less than -1, or is 3 bigger than or equal to -1? Well, of course, 3 is bigger than -1, so now I'm going to use the bottom rule, and that's going to give me 3 times 3 plus 4. Again, replacing that x with my input 3, and I get 13. So you can see the kind of process of evaluating a piecewise function. All right, determine which rule you're using first, and then plug in your value. All right, just to show a difference, our next example now is split into 3 parts. Just because I don't want to get too complicated, generally I'll keep it to 2 or 3 parts for the practice ones. I think on the practice there might be one that has 4 parts, all right, but the process is still the same. You still have to do the same types of thing. All right, g of -2. All right, the first thing to do is figure out with -2, which rule do I fall into? So again, I'm going to write them all out. You don't have to do this every time, but I'm just going to write them out to show what we're doing. All right, is -2 less than or equal to -2? Is -2 bigger than -2 and less than 2, or is -2 bigger than or equal to 2? And a -2 is exactly the same as -2, so because of this equal sign here, it tells me I'm going to plug this into the top rule. All right, so when you're on the border, make sure you use the one that has the equal sign. That's going to be negative 2 squared minus 1, 4 minus 1, and that's 3. All right, so when I'm plugging in exactly negative 2, I'm using the top rule. All right, when I'm plugging in 1, which is next, again, I'm asking myself, if I replace these x's with a 1, which category do I fit in? Well, 1 is between negative 2 and 1, so I'm going to plug it into the middle rule, and that just simplifies to 1. And lastly, g of 2, I'm exactly equal to 2, which tells me I'm using the bottom rule. And we haven't had very many functions that look like this where there's no x. Well, if there's nothing to replace with, I'm just going to get 2. I just get whatever that number, and these are called constant functions. It just tells me no matter what I plug in, I just get out 2, because there's no x that's going to change anything. So in this one, I plug in 2, I just get out 2. All right, so now here's one to try on your own. So you have this piecewise broken into 2 pieces, evaluate h of 2. All right, and here's what I got when I did this. 2 is bigger than 1, so I'm going to use the bottom rule, and I plug in 2 there, I get 5. All right, the main focus of this learning objective is just plugging values into piecewise, but I also just want to quickly talk about when you're solving in relation to a piecewise. So this is actually a lot more work, because when you're solving a piecewise function equal to a number, basically you have to solve each part as its own individual problem, and then make sure that actually that solution is being used in that part where the piecewise is. So let's talk about what I mean. So I want to find all x-intercepts of this piecewise function. But we know an x-intercept from a previous learning objective. We know an x-intercept is when our function is equal to 0. All right, so what I actually have to do is break this down into multiple problems. 2x plus 1 equals 0, and 3x plus 4 equals 0. Because those are all the possible rules that my piecewise could use, and any of those could be 0. So in this one, I subtract 1 and divide by 2. In this one, I subtract 4 and divide by 3. And just to help us out, the decimal approximations, this is negative 0.5, and this is negative 1.33. So those are my possible x-intercepts, but I have to make sure these x-intercepts occur when I'm actually using the rule. All right, 2x plus 1, I only use that rule if my x value is less than negative 1. So if I was using 2x plus 1, the x-intercept would occur at negative 1/2, but that's not less than 1. So this is actually not an x-intercept for this piecewise function, because with the place where the x-intercept would occur is not when I'm using that rule. All right, and for the other one, 3x plus 4, all right, that x-intercepts occur at negative 1.33, but negative 1.33 is not greater than negative 1. So also this one is not actually a real x-intercept, because the place where it would happen is not where I'm actually using the bottom rule. All right, so actually this piecewise function has no x-intercepts. All right, so here's one for you to try on your own. I accidentally left example here. Go ahead and try this on your own. I forgot the x-intercepts of this function g of x would be. And this function actually turns out it does have an x-intercept. So if you solve 2x plus 4 equal to 0, you get negative 2. And negative 2 is equal to negative 2. So we would be using this top rule when its x-intercept would occur. All right, so this actually is an x-intercept for the graph of g of x. For 3x plus 9, that x-intercept would occur at negative 3. But negative 3 is not bigger than negative 2. So this is another x-intercept that would happen if we were using that rule, but we're not using that rule at that location, so we kind of just cross it out. All right, so this one actually has one x-intercept at negative 2. All right, so now it's time to practice. All right, the main thing this learning objective is testing is, can you plug values into a piecewise? So the solving part's not covered in the skill check. All right, so make sure in the practice, you practice plugging in values and making sure you understand how piecewise functions work.